Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so question 2 says the letters A to H in the table below represent 8 organic compounds, right? So we know the strategy. Let's first identify where each and every organic compound in this table belong, right? So we have A with the Br here, we can see that this belongs in the haloalkane. And then B with the double bond between the carbon atoms here, we can see that this belongs in the alkene. And then C, again here, we can see that this belongs in the alkene because of the suffix in. And then D, because of the CHO, can see that this belongs in the aldehyde. And then E, butan 2-on, because of the suffix on, we can see that this belongs in the ketone. And then F, because of the suffix -wine, we can see that this belongs in the alkyne. And then G, because of the suffix -ane, can see that this belongs in the alkane. And then H, because of the Cu, we can see that this belongs in the carboxylic acid. Okay, so now let's get down to the questions. So 2.1 says, write down the letter that represents a compound that is a ketone. Which one is a ketone? It's letter E. Then 2.1.2 has the general formula CnH2n-2. So which one is an alkyne? It's F. And then 2.1.3 is an isomer of 2-methyl-but-2-ene. Is an isomer. So they did not specify what type of isomer, but then let's check here. 2-methyl-but-2-ene has to have 5 carbon atoms. So it's the 4 carbons in the longest chain plus the carbon that will be in the methyl branch. So that's 5. And then looking at C, we can see that this is pent 2-ene, which obviously has to be the one that has 5 carbons as well. So it has to be C. Then 2.1.4 has the same molecular formula as ethyl ethanoate. The same molecular formula as ethyl ethanoate. Now, ethyl ethanoate is an ester, and then we know its isomer needs to be a what? A carboxylic acid. So functional isomer needs to be a carboxylic acid. So it obviously, without even having to confirm, we are pretty much sure that it has to be H. Right. And then ethyl ethanoate has 4 carbon atoms. Let's count. We have 1, 2, 3, 4. So exactly. Then 2.2, write down the IUPAC name of compound A. So the IUPAC name of compound A. Let's discover our longest chain here. This is 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So the longest chain is definitely the straight chain. So we can take our straight chain as the longest chain. So there's 6 carbon atoms. Then okay, let's now see this one. So we have starting from here, because we can see this is the side that is the earliest disturbance, and then it has more disturbances, because even counting from here 1, 2, we have a methyl branch, but then here we have 1, 2, this is a methyl branch plus a bromo. So obviously we would have to start counting from this side where we see more disturbances or more substituents. So that's 1, 2, and then we have 3, 4, 5, 6. So these are occurring in number 2. So it has to be what? So 2.2.1. We have a methyl in number 2, and then we have another methyl in number 4, And then we also have another methyl in number 5. So, and then in number 2, we have a bromo. So this has to be 2 bromo, and then dash in number 2, in number 1, 2, 3, 4, in number 4, and then also in number 5, we have a methyl. So that's trimethyl. So let me write it here. That's 2 bromo, and then 2, 4, 5 trimethyl. And then the longest chain, we said it has 6 carbons. So that's trimethyl hexane. Right, so that's the name. 2 bromo 2, 4, 5 trimethyl hexane. So that for 3 marks. Then 2.2.2 says the structural formula. So let's indicate this was for 2.2.1. And then 2.2.2 says the structural formula of compound F. So to draw the structural formula, we have pent indicating our longest chain must have 5 carbons. So that's 1, 2, 3, 4, and then 5, right? And then in number 2, we must have our triple bond because wine. And then in number 2, we have our triple bond like that. Then in number 4, we must have our methyl branches. So 1, 2, 3, 4. It's a methyl branch here. And below another methyl branch. Okay, then let's just fill in the hydrogens where we need to. So here we cannot fill in the hydrogens because look, 1, 2, 3, 4. It's already complete. 1, 2, 3, 4, complete. Then we have to fill them here. So that's the structural formula of 4,4-dimethyl pent 2 wine. And then let's proceed to 2.3. So 2.3 says for compound D, write down the homologous series to which it belongs. So compound D, we said this is an aldehyde. And then 2.3.2, name of its functional group. The functional group of an aldehyde is formyl group. And then now they're saying structural formula of its functional isomer, right? The functional isomer to an aldehyde, we already know is a ketone. So this is 1, 2, 3, 4, right? And then to draw its structural formula, the structural formula of its functional isomer, let's maintain that we still have 4 carbons, right? And then we can just go ahead and have our double bond in the carbon that is in between other carbon atoms. So just like that, now we have our structural formula, which even if you were to look at this one, it is actually E. The functional isomer of D is actually E. So this is more like you were drawing the structural formula for E. Then 2.4 says for compound G, where is compound G? Butane. Write down the IUPAC name of a chain isomer. Write down the what? The IUPAC name of a chain isomer. So in order to create a chain isomer from this has 4 carbon atoms. So to make a chain isomer, we should just maintain that we have 4 carbons, but then create a methyl branch here, right? So it's still 1, 2, 3, 4, and then we can just create a methyl branch there. Then just like that, I've formed a chain isomer. Now, what do they want? They want the IUPAC name. So the IUPAC name has to be what? 2-methyl, and then 2-methyl propane, right? So that's supposed to be 2-methyl propane, right? And then that's the IUPAC name for 2 marks. Now 2.4.2 says a balanced equation using molecular formulae for its complete combustion. So once again, we can see that question is very much common. So we know that every time we are facing combustion, the general formula is that you should always have an alkane reacting with O2 to give you CO2 plus H2O, right? Now, what is our alkane? Our alkane is a compound G, which is butane. Now we know the molecular formula for butane is C4H10, right? So using the formula CnH2n plus 2, right? So if we have 4 here, that's 2 times 4, 8 plus 2, that's 10. So now let's do it here, C4H10, and then reacting with O2, to give us CO2 and water. So I'm trying to leave spaces here so that I balance here. And then, okay, now we know for the balancing, we use the Chor method on the left-hand side and then Chor method on the right-hand side. Okay. And then here we go. How many carbon atoms on the left-hand side? 4. But how many on the right-hand side? Only 1. What integer value can I multiply to 1 so that I get 4? That's 4. Then just before the carbon here, I put that 4. Then how many hydrogens do I have this side? That's 10. And then this side I have 2. But then what integer value can I multiply so that I get 10? It's 5. So multiply that by 5. Then I need to put the 5 just before the H2O there. Now, how many oxygens on the left-hand side? As we can see, there are 2. But then how many on the right-hand side? This is what we are supposed to do. 4 times 2, that's 8. But then 5 times 1, that's 5. So 8 plus 5, that will give us 13. So I'm supposed to say 13 here. But then what integer value can I multiply to 2 so that I get 13? 13 is an odd number, so there's no integer that I can multiply with 2 to get that odd number there. So what am I supposed to do? Now I'm supposed to take the 13 and divide it to the 2. So I will say 13 divided by 2, and then this obviously will give me 13 over 2, and then I just put it here. But then remember, I cannot balance with a fraction. I need to get rid of this 2 here so that it is no longer a fraction. So what am I supposed to do? I need to multiply both sides by 2. So when I multiply both sides by 2, this will now be what? So I now have the 2 here, but then note that the compounds will not change. This is still C4H10. But if I multiply the 2 and the 13 over 2, I'm left with the 13 there. And then this is still what? O2. Then if I say 2 multiplied by 4, that's 8. So I will have my 8 here. And then this is still CO2. If I say 2 multiplied by 5, that's 10. And then I still have my H2O here. Now let's check and see if this is balanced. Let's check and see if the sides are now balanced. So from this, we'll say how many carbons are on the left-hand side? That's 8 now, 2 times 4. And then on the right-hand side, that's 8 times 1, still 8. And then how many on the left-hand side, hydrogens? 2 times 10, that's 20. And how many this side? That's 10 times 2, that's 20. But how many oxygens? That's 13 times 2, it's 26. And then here we have 8 times 2, that's 16. Then plus 10 times 1, which is 10. 16 plus 10 is also 26, right? So the left-hand side is equal to the right-hand side. That means the equation is balanced. That's how you were supposed to approach this question, guys, for a total of 19 marks. So please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.